In this video, I'll be looking at the motion of a body along an inclined plane as a ram or a surface that is inclined at this angle theta degrees to the horizontal. Now, let's suppose that this body of mass m is on this plane. And first of all, we need to draw the free body diagram. That is a diagram that shows all the forces acting directly on the body of mass m. So here's the free body diagram. First is the weight of the block of mass m. Recall that the weight of the body acts vertically downwards, and it is given by the product of the mass of the body and acceleration due to gravity or gravitational field strength. Now there's a normal reaction that is acting from the surface of the inclined plane, and that acts in this direction, the normal force. You can call that Fr or Fn, sorry. You can call that Fn, that's the normal force. Okay, so here you can see that the two lines of action, the normal force and the weight line, they are not in the same direction. Okay, so if you check now, this is a right angle triangle. Okay, this is angle 90. I expect that this angle will be theta minus 90 because these three angles must add up to 180 degrees. Okay, so I'll produce this normal line in this direction. Okay, I'll produce that so that it's now possible to complete this figure so that I can make it up to a right angle triangle. This is my 90 degrees. Okay, so by similar triangle, this particular triangle is similar to this. Therefore means that this angle will also be theta degrees. So if the angle of inclination is 30 degrees, therefore means that this is going to be 30 degrees as well. So whatever angle this is the same as this particular angle. Now we can resolve the weight line, that is the weight of the body acting along this direction. It has two perpendicular components. There's a component of the weight line that is acting along this line, which is the same as the component acting parallel to the plane. Okay? Okay, so you can see that now. The component of the weight acting along this line is parallel to this line. So let me call that component Wx. And then there's a component of the weight that acts perpendicular to the plane. Let me call that Wy. In my last video, I went through this, but I'm also doing this so that you can see the case where the forces acting along the direction of motion can cause acceleration, that is, can accelerate the body. Okay? So, using this right angle triangle and then using the trig function, I can define my sine theta as opposite, that is Wx, this is my Wx, over the hypotenuse, which is the weight, and the weight of the body is mass times this. So my Wx is equal to mg sine theta. Okay, so that's the same thing as a component of the weight that is acting along the plane, that is down the plane or parallel to the plane. Okay, now if I resolve perpendicularly, I'm going to have the adjacent, that is cos theta, adjacent, which is Wy over mg, so that my Wy component is equal to mg cos theta. Now this is mg cos theta, the component of the weight mg that is acting at right angles to the plane surface. Now what happens if a force P is applied this way? Let's call this force P. is applied this way to pull the block of mass up the plane. That is the case we are considering now. Now, let's see some cases. Case 1. Suppose the plane is smooth. You have number 1, smooth plane. There is no frictional force acting between the block and the plane surface. Smooth plane. When I say no frictional force is acting, it means that the frictional force Fr is 0. It also means that the coefficient of friction, whether static or dynamic, is also 0. Now, there are three possibilities here. Number 1, under smooth inclined plane. If force P is equal to mg sine theta, it means that this block will move up with a constant speed. If these two forces are equal, because they act in opposite direction, and we're looking at a case where there's no frictional force acting between the two surfaces. If force P equals mg sine theta, that's a case where the resultant force on the body, let me use F as a symbol of my resultant force, which is the difference between the force acting in the direction of motion, because this is the motion of the block up the plane. So this is in direction of motion. So I give that positive, and then this one is moving against the direction of motion. I give that a negative sign. Or we can quickly draw our coordinate system. Coordinate system. We have the x and the y coordinate system. Okay, this is my x, this is my y coordinate system. I can place it here. So any force that is acting to the positive direction of x, to the right of x, we can give that force positive. Any force acting this way will be assigned a negative sign. Any force acting up along the y-axis will be given the positive sign, and any force acting below the plane will be given a negative sign in the y direction. So that's the essence of making this positive, or assigning a positive sign to this and a negative sign to mg sine theta. Okay, so that's the resultant force, which equals mass times acceleration according to Newton's second law of motion. Okay, now since the block moves with a constant speed, that is to say, if this equals this, it means that F is equal to, the difference between these two will be 0, because both of them are equal. Suppose P is 10 Newton and mg sine theta is also 10 Newton. Of course, 10 minus 10 gives 0. It means resultant force is 0 and acceleration of the block up the plane is also 0. This is the case where the block moves with a constant speed or velocity. Okay, that is case 1. Now, case 2, suppose that force P is greater than mg sine theta, still considering the case where there is no frictional force acting on the between the surfaces. Now, it means there is going to be a resultant force. It means in this case, the block of mass accelerates. That's what happens. Accelerates up the plane. It accelerates up the plane if force P here is greater than mg sine theta. Okay, so means in that case, the resultant force is the difference between the force P and mg sine theta, which equals, according to Newton's second law, mass times acceleration. Okay, so if I'm asked to calculate the acceleration of the block up the plane, then I can say from these two sides of the equation that A equals P minus mg sine theta over m. Okay, so this is when you are asked to calculate the acceleration of the block up the plane. Suppose force P is known, the mass of the body is known, and you are asked to take the value of acceleration due to gravity as 9.8 meters per second squared. And let's say sine theta is also known, or theta is known, even maybe it's 30 degrees or so. From this, you can calculate the acceleration of the block of the plane. And again, they may ask you that suppose the block is pulled from rest and the length of the plane is given, you'll be asked to calculate the speed of the plane We also calculate the speed of the block at the top of the plane. Okay, so that's on one case. Or sometimes we'll be given the acceleration of the block of the plane. And we have to find the value of force P from this same equation. If I want to calculate the value of force P, suppose you are given the acceleration, or there's a way of calculating the acceleration of the block up the plane. Then for this equation, we know that the force P will be equal to mg sine theta plus ma. That gives the value of the force P that pulls the block of mass up the plane. Okay, so let's say the third case, case C, if the force P is less than mg sine theta. Now, in this case, we still see that this block is in this motion up the plane. It's still going up the plane. It's not a case where the force P is equal to zero or the force P has been removed. No, the force P is still being applied to the block. But this time around, the value of force P, which is applied to move this block, is now less than mg sine theta. It means in this case, the block of mass is decelerating. In that case, it means the block of mass decelerates while still moving in the direction along or up the plane. Okay, so the resultant force here is P minus mg sine theta, which gives you ma. Okay, so in the case of deceleration, the acceleration is given a negative sign. It's given a negative sign, which now equals P minus mg sine theta is equal to m times minus acceleration. So I can determine my force P. The expression for the forward force P is now given as mg sine theta minus ma because of this negative sign. So this is how to calculate the force P if the block slows down, that is to say decelerates as it moves up the plane. And sometimes it's also possible to calculate the, the deceleration. In that case, when you apply this same equation to calculate the deceleration, you still arrive at a negative value for the deceleration of the block. Suppose that this force P is less than mg sine theta. Alright, so we have that as the case where the force P is less than mg sine theta. Okay, let me come back here. Now, when the resultant force on this block is zero, okay, it means that the forces balance and they cancel out each other. Two things happen when the resultant force on this block is zero. It is either that the block is moving at a constant speed or the block is at rest when the resultant force on this block is zero. Okay, that's the state of because there are two types of equilibrium. We have the dynamic equilibrium and then we have the static equilibrium. In both cases, the net force on the system is equal to zero. Okay, now okay, let's consider this question. A block of mass 30 kg rests on a smooth plane inclined at 20 degrees to the horizontal, and then a force of 120 Newton pulls the block up the plane. We are to calculate the acceleration of the block up the plane. Something like this. Okay, this is the angle of inclination of the plane, 20 degrees. Let's call this a block of mass. I hope I'm doing it well. Now, this block of mass rests on this plane, and the weight of this block of mass is its mass times acceleration due to gravity, which is 9.8. Okay, Newton, that is the weight of the block. Now, already we have done that before now, that there is a component of the weight of the block acting along or down the plane. That component is the mg sine theta. That is 30 times 9.8 times sine theta, or sine 20 degrees. That's the component of the weight that is acting down the plane. And then we have the force P that is also acting parallel to the plane. And we are given that force P at 120 Newton. That's the force that pulls this. That's the free body diagram of this block of mass, showing the forces acting on the plane. We also have the normal force. The normal force always acts in a direction at right angles to the plane. Normal force, let's call that Fm. Okay, but along the plane, we have two forces acting. This other one, if I produce the normal force, there's a component of the weight, which is m, that balances the normal force. And since there's no motion along this direction, we're only going to work with the forces acting along the direction of motion. And since the block moves in this direction, it means that the resultant force on this block, F, will be equal to force P minus mg sine theta. And since we are asked to calculate the acceleration for Newton's second law, it is equal to mass times acceleration. Now, this force P is 120, is given to us, minus this is 30 times 9.8 times sine 20 degrees is equal to the mass of the block, 30 times acceleration. Okay, so I have to quickly compute this. I'm sure you are there with your calculator, so take it up now and let us work together, okay? So if you multiply this by 9.8 and then multiply by the sine of angle 20 degrees, this gives you roughly 100 point, approximately 0.6, okay? That equals 30A, okay? Wow, I'm sure you are really following and you have confirmed that. Okay, so quickly, let's find the difference between these two numbers. 120 minus 100.6. My answer is 19.4. I got 19.4 as my answer. That equals 30A. And my A is acceleration, and that's what you have to find in this question. That gives you 19.4 divided by 30. Okay, so help me there. Divide that by 30. What does it give you? Oh, mine answer here is 0.65 approximately meter per second square. So this gives the acceleration of the block of the plane. And then again, suppose you are given the length of the plane. We're going to calculate the time taken or the speed of the block if this acceleration is maintained from the start to the top of the block. Then we're going to calculate the speed of the block when it gets to the top of the plane. Okay, in the next video, we are taking more questions on this. Thank you very much.